Next topic is bond order. In molecular orbital theory, we have defined that atomic orbitals from the various atoms combines to produce the molecular orbitals. And in molecular orbitals, the electrons are distributed in the bonding orbitals and the anti-bonding orbitals. And depending on the number of electrons in these orbitals, we can define bond order as equal to, this is BO, bond order equal to number of electrons in the bonding orbitals minus number of electrons in the anti-bonding orbitals divided by 2. Using this formula, we can calculate the bond order for the different molecules. For example, number 1, here BO is bonding orbitals and ABO, it is the anti-bonding orbitals. The first we take hydrogen 2 plus. This is the hydrogen molecule, and out of which one electron has been ionized. That means it has only one electron. So its configuration will be, as per the molecular orbital theory, it is sigma 1s1. Therefore, this sigma is the bonding orbital. That means number of electrons in the bonding orbital equal to 1 and number of electrons in the anti-bonding orbital equal to 0. We can say bond order is equal to 1 minus 0 by 2. That means it is 0.5. Similarly, we will write some bond order for the different molecules and ions. For example, H2, it has 2 electrons in the orbitals and it is distributed as sigma 1s2. So bonding orbitals has the electrons 2, anti-bonding orbital has electrons 0, and this implies that bond order is 1, 2 minus 0 by 2, that is equal to 1. Third, He plus, it has 3 electrons, so its configuration will be sigma 1s2, sigma star. Now it is the anti-bonding orbital and it contains only 1 electron. Therefore, number of electrons in the bonding orbital will be 2, in anti-bonding orbital will be 1, and bond order will be equal to 2 minus 1 by 2, that is equal to 0.5. Fourth is say helium. It has 4 electrons. Configuration is sigma 1s2, sigma star 1s2, and bonding orbitals are 2, anti-bonding orbitals are 2, and we can say bond order is equal to 2 minus 2 by 2, that means 0. We can say this He2 will not exist because there is no bonding. Next is lithium 2. It contains 6 electrons. So we can define it as sigma 1s2, sigma star 1s2, and sigma 2s2. Therefore, it has number of electrons in the bonding orbitals are 4 and in anti-bonding orbital it is 2. Therefore, bond order will be equal to 4 minus 2 by 2, that is equal to 1. Next is say beryllium 2. It contains 8 electrons and we can configure it as sigma 1s2, sigma star 1s2. Star refers the anti-bonding orbitals, and which do not have the star, they are the bonding orbitals. Then sigma 2s2, sigma 2s2 star 2, sigma star 2s2. So bonding orbitals are 4, anti-bonding orbitals are 4, hence bond order will be 4 minus 4 by 2, that will be 0. Next we take boron B2. It will have 10 electrons. Its configuration will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, and next 2 electrons will go into the pi orbitals, that is pi 2p y1 and pi 2p z1. These pi orbitals will be of the same energy. We can say these are the degenerate orbitals having the same energy, and electrons will go in the both orbitals one by one, following, or we say obeying the Horn's rules, which say the maximum unpaired electrons results into the stable configurations. So it obeys the Hund's rule for the 1 electron in 2p orbital and 1 electron in 2p orbital. Therefore, we can say it has the number of bonding orbitals. It is 2, 4, 5, 6. 6 are the bonding orbitals and 4 are the anti-bonding orbitals. Therefore, bond order will be equal to 6 minus 4 by 2, that is equal to 1. Next is C2. It has 12 electrons in their orbitals and configuration will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Then the next electron will go into the pi orbitals, pi 2py2, pi 2pz2. So number of the electrons in the bonding orbitals will be 2, 4, 6, 8, 8 electrons, and number of the electrons in the anti-bonding orbitals will be 4. Therefore, bond order will be equal to 8 minus 4 by 2, that is equal to 2. On the same basis, we can also write for nitrogen. It is 14, and we can configuration will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, then pi 2py2 and pi 2pz2. This py and pz will have the same energy. They are the degenerate orbitals, and next two electrons will go into the sigma 2px orbital, and it has the 2 electrons. So number of electrons in the bonding orbital will be 2, 4, this 2, 4, 6, 8 and then 10. And in anti-bonding orbitals will be 4. Therefore, bond order will be equal to 10 minus 4 by 2, that is equal to 3. That means nitrogen will exist in the form of N2, which has the triple bond in between them. This bond order refers the number of the bonds. So bond order 3 means it is a triple bond. If bond order is 2, that means it refers the double bond. If bond order is 1, then it refers the single bond. Similarly, we can write the configuration for oxygen, which contains 16 electrons, and it will have sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Then here there is a change in the energy of the orbitals in case of the oxygen in comparison to nitrogen. In oxygen, the energy of 2px orbital is lesser than the pi orbital. So we can write it is 2px2, then pi 2py2, pi 2pz2, and remaining will come into the pi 2p pi star. This is the anti-bonding orbital, 2 pi x1, pi star 2pz1. So in this way 16 electrons in the oxygen are distributed, and if we check, the number of electrons in bonding orbitals will be 2, 4, then 6, 8 and then 10. 10 electrons are distributed into the bonding orbitals, and remaining 6 electrons will be distributed into the anti-bonding orbitals. So bond order will be equal to 10 minus 6 by 2, that will be equal to 2, and it exists in the form of O double bond O. For O2 minus, then it will contain 17 electrons, and it will contains the same configuration as here. Only the changes is it will contain pi star, that is the anti-bonding orbital, 2py2, and then pi star 2pz1. Similarly, if we write O2 2 minus, then it has 18 electrons, and configuration will be like this, and in the last it will have pi star 2py2, and next electron comes into the next anti-bonding orbital, pi star 2pz2. If we check here, number of the electrons in the bonding orbital is still 10 and 10, but here one more electrons come into the anti-bonding orbital, so it has 7 electrons, while the O2 2 minus will have 8 electrons. Therefore, bonding order will be 10 minus 7 by 2, that is equal to 1.5, and in O2 2 minus it is bonding order is 10 minus 8 by 2, that is equal to 1. And also if we write the configuration for NO, which contains 15 electrons, then configuration will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, then 2px2, and then these pi orbitals 2py2, pi 2pz2, and after that it is having the pi star 2py1 and pi star 2pz0. So in this way it will have 10 electrons in the bonding orbitals, while the anti-bonding orbital will have 2, 4 and 5 electrons. So therefore bond order will be equal to 10 minus 5 by 2, it is equal to 2.5.